Hi everyone, this is topic 4.9 Oxidation Reduction Redox Reactions. This is taken from AP Chemistry College Board. Till now in topic 4.8 also I told you that there are many types of reactions. Out of that, one is oxidation reduction reaction also, and it is also called as redox reaction. Now, what are the redox reactions? Redox reactions are the reactions in which the oxidation and reduction are taking place at the same time. Some of the common examples of redox reactions are combustion, corrosion, respiration, photosynthesis, and also some of the reactions which are happening in the electrochemical cells. So these are some of the examples of oxidation reduction reactions or redox reactions, you can say. Now, how do we get to know if the reduction or oxidation is taking place or not? So reduction is the gain of electrons and oxidation is the loss of electrons. And there's a mnemonic for this, RIGOIL. RIG, it means reduction is gain of electrons, and oil is oxidation is loss of electrons. So with this way you can learn that what is oxidation and what is reduction. Before going into the details of the oxidation and reduction reactions, let me first tell you about the valency table, because this is what is very important to write down the ionic equations, and from there you can get to know if the reduction and the oxidation is happening or not. So this valency table basically tells you that what are the valency of the elements in the periodic table. Now, all the elements of the same group are having the same valencies. For example, if we are talking about group 1 elements, they have +1 valency because they can easily lose one electron to have fully filled shell. Similarly, group 2 has +2 valency. Group 3 has +3 valency. Group 4 can have +4 or -4 valencies. Group 5 can have -3 valency. Now -3 tells you that it can gain the 3 electrons to get the fully filled shell. Group 6 can have -2 valency. Group 7 can have -1 valency, and group 8 will be having 0 valency because it is already having fully filled shells, so it will not gain or lose any electrons. Now let's see an example of writing the ionic equation. Now suppose you are given the word equation, that is magnesium plus copper sulfate gives magnesium sulfate plus copper. First of all, you need to write down the balance symbol equation. The balance symbol equation will be magnesium will be written as Mg, copper sulfate will be written as CuSO4, magnesium sulfate can be written as MgSO4, and copper will be written as Cu. Now we have to see that if it is balanced or not. In this case, it is already balanced. Now how to write the ionic equation? The ionic equation of this symbol equation will be Mg plus Cu2 positive gives Mg2 positive plus Cu. Now how did we get this ionic equation? Let's see all the steps which are involved. I told you that the balanced equation will be copper sulfate, that is CuSO4, plus Mg gives MgSO4 plus Cu. Next thing is to write out all the ions and atoms. For example, for copper sulfate it will be Cu2 positive and SO42 negative. Mg will be written as Mg only because it is in element form. Then we put an arrow, and then magnesium sulfate will again be split as Mg2 positive and SO42 negative, and then copper will be written as copper only. Only the metal compound is to be broken down into the ions. Okay, for example, if you are seeing this compound, this will be only broken down into ions, that is metal cation and an anion. Single metal will remain same, either it is in reactant or product side, it will remain same only. Next step is to cross out all the spectator ions. Spectator ions means the ions which are same on both the sides. For example, here the sulfate ion is a spectator ion, so we'll cut out that. Copper 2 positive cannot be cancelled with copper because here it's in ionic form and here it's in element form, so it will not be cancelled. Similarly, Mg will not be cancelled with Mg2 positive, so they will remain as such. Next thing is to write down the ionic equation with what is left. So what is left here is copper 2 positive plus Mg will give Mg2 positive with copper. Okay, so this is the final ionic equation of this whole simple equation. Now next thing is to see that what is being oxidized and what is being reduced. So for that we have to write again the ionic equation, that is copper 2 positive plus Mg will give copper plus Mg2 positive. Now next thing is which of these is being oxidized. Now you know that oxidation is loss of electrons. Loss of electrons, it means that the electrons are coming out. The electrons will only be coming out if the element is changing into the ionic form. So this is the one which is being oxidized. And copper 2 positive is being reduced. Why? Because copper 2 positive is changing into copper. And how it can convert into copper? By gaining the electrons. So the half ionic equations will be Mg is changing into Mg2 positive plus 2 electrons. You have to write the same metal in the same ionic equation. So it will be Mg is giving Mg2 positive. As it is changing into cation, it means that it is giving away the 2 electrons. And on the other side, copper 2 positive is changing into copper. And how it can be converted into copper? By gaining the 2 electrons, because this is the cation form. Cation form means it is less in electrons. So to convert into element form, it has to gain the 2 electrons to change into copper. And these displacement reactions are also called as redox reactions. Why? Because the copper sulfate changed into magnesium sulfate. So it means that copper is basically displaced by magnesium. So there are three names for these types of reaction: oxidation reduction reactions, redox reactions, and the displacement reactions. Sometimes in the exam you get half ionic equations and you have to write down the complete balanced overall reaction. So let's see how can we write it down. For example, you are given these equations. Na gives Na positive and Au3 positive gives Au. Au is the gold. Now, first of all, you have to write down the balanced half reactions. That is, Na is changing into Na positive. How can it change into Na positive? By giving the electrons. So we will write Na will give Na positive plus electrons. And on the other side, Au3 positive is changing into Au. Now, as you can see here that it is 3 positive, it means that it's gaining the 3 electrons. So the reaction will be Au3 positive will gain 3 electrons. So it is plus 3 electrons will give Au. Now the next thing is writing the balanced half equations. And how will it be? As you can see here that Au is gaining the 3 electrons, but here the sodium is only giving 1 electron. So it means that we have to put 3 here, 3 electrons here. But how will it change into 3 electrons if the whole equation is multiplied by 3? So it will be 3 Na. It will give 3 Na positive plus 3 electrons. Now what we will do next, we will cancel these three electrons, and the final equation will be 3 Na plus Au3 positive will give 3 Na positive plus Au. Whatever are the species on the left hand side of the arrow, you have to write it on the left hand side only, and the right hand side products will be written on the right hand side of the arrow. So this is how we write the whole combined equation if you are given the unbalanced half reactions. I hope the topic is clear to you. If you like the video, please subscribe to my channel Log Iota and press the bell icon.